Hi, everybody. Today, this little segment is just on single replacement reactions. And so when we're looking at single replacement reactions, remember that they have the general formula that looks like this. A plus BC going to AC plus B. This is the general formula where A is an element, BC is a compound. And remember, compounds, cations are always written first. So B is the positive or cation and C is the anion, negatively charged. And so when it's of this general format and the element A is a metal, we're able to form a cation. A will switch places with B. So notice in our product, A is with C and B is on its own. So A is now in the compound and B is now the element. There's one other type of single replacement reaction that can happen. We could still use A plus BC, but I'm going to use Y, well, let's do X plus YZ. Same thing, this is an element and this is a compound. And again, the positive cation is always written first, so it looks very similar. But in this case, X would be an element that forms an anion, not a cation. So in the first example, A is an element that forms a cation, so it's going to switch and become AC. If the element is something that forms an anion, it's not going to switch places with the cation Y, it's going to switch places with the anion Z. And so my products here would be YX and Z would be on its own. So in this case, Y forms an anion. In this case, A forms a cation. So I'm going to show you through examples how you would know this, and then how do you predict what the products are going to be. So what we're going to need to do in order to work through these single replacement reactions is use the activity series. I put two separate handouts show activity series that are posted on Canvas for you. One is embedded in a worksheet that's only for practice. It's not going to be collected. And the other is just a singular page of the activity series. Let me show you, let me see if I can get to where that is. So here is here is an activity series. All right, so if this is our activity series, what it's going to show you is things up on the top, lithium, rubidium, potassium, are more reactive than things on the bottom, like silver, platinum, and gold. Also, for the ones that form anions, which are basically only the halogens, fluorine is more reactive than chlorine, more reactive than bromine. So when you're looking at these reactions, what's going to have to be true is we're going to need, if the reaction is going to happen, the element that's singular has to be more reactive than the element in the compound in order for the reaction to happen. So you're going to need to refer to the activity series in order to do this. So you might want to open up the file on your computer so you can watch along with what we're doing. So let's look at the first example on the sheet. If I can go back to my whiteboard. Oh, well, I'll just do it on here. Okay, so on that handout, the very first example, oops, maybe I can't do this. There we go. On my example, the very first problem is silver plus potassium nitrate. So if I look on the activity series, what I see on the activity series is that potassium is way up on the top and silver is way down here towards the bottom. What that means is potassium is more reactive than silver. And so if I try to run this reaction, what I'm actually going to get is no reaction. Because silver is not reactive enough to replace potassium. Potassium is more reactive and it will be part of the compound. So number one on the worksheet is just going to be no reaction. If you look at number two on the worksheet, we have zinc, messy. Let me start over on a new sheet. we have zinc plus silver nitrate. Now I'm being very lazy, and the worksheet I posted is kind of lazy in that it doesn't have states of matter for these things. And so really what you would normally see is solid and AQ. But in the next video, I'm going to talk more about the soluble and insoluble things. So for right now, let's just get what's going to replace what. And so if we look at this one, what we see is that zinc is higher on the activity series than silver. So this reaction will happen. So what's going to happen is zinc is a metal. It forms a cation. It's going to switch places with the silver. Now you have to watch out for charges. This is a good example with zinc and silver because I don't know if you recall, but I had asked you to remember 3 of the metals that you can't tell their charges necessarily based on their locations, but zinc and silver were 2 of those. You needed to remember that zinc is always +2, and you needed to remember that silver is always +1. So if I know that silver is +1, AgNO3 is really Ag1+ and NO3 1-. This is my cation. This is my anion of my compound. And then I have zinc. Right now it's solid, elemental neutral atom. When my reaction takes place, since zinc is more reactive than silver, zinc is going to replace silver in the compound. And so what I really want to end up with is, in name, I want to end up with zinc nitrate and silver atoms. So what is the formula for zinc nitrate? Well, zinc makes ions that are +2, and nitrate ions are only -1. So zinc +2, nitrate -1, I need to have 2 of these things in my formula. So I'm going to have zinc NO3 2, and then my other product will just be silver. So when I'm doing this, what's going to be true is I have to then balance the equation. So in my equation, I have 1 zinc and 1 zinc. I have 1 silver and 1 silver, but I have 1 nitrate, and over here I have 2 nitrates. So I'm going to need to put a 2 in front of the silver nitrate, but now I have 2 silvers. So I'm going to need to put a 2 in front of the silver. So when it's all said and done in a nice, more clear way, I would have this as my reaction, zinc plus silver nitrate. Oh, I shouldn't have put parentheses there, sorry. It's going to go to zinc nitrate 2 plus silver, and to balance it, I need 2 of these, and I need 2 of those. So let's skip down and do number 4 on the worksheet together, just so you have one more example. And then there are 20 problems you can try on the sheet, and the answers to them all are already posted at the bottom. Just keep scrolling on the single replacement worksheet page. There's a page in there for the activity series, and then there's a page of all the answers. But let's just do one more together. So this is number 4 on that sheet. Chlorine plus potassium iodide. Now this is a little bit different because chlorine is an element that forms an anion, right? Forms anion. How do I know that? Chlorine is a nonmetal, right? And so if chlorine's going to react, chlorine's not going to replace potassium, which is my cation. It's going to replace iodine, which is my anion. So now I have to look on the activity series to see which one is more reactive. And for the halogens, it goes fluorine, chlorine, bromine, and iodine. This is the most reactive, and this is the least reactive. So chlorine is in fact more reactive than iodine, and it will replace it. Chlorine is also a diatomic element. Remember, all the halogens are diatomic elements, so that's why it's written as Cl2. So what's going to happen here is I'm going to take chlorine, and right now I have potassium and iodide ions, and I'm going to end up getting the potassium is going to go with the chloride, so I'm going to end up with, if I could spell, potassium chloride plus iodine. So the chlorine and the iodine are going to switch places. Potassium is 1+ and chlorine is 1-. How do I know chlorine's 1-? Because chlorine's in group 17. It has 7 valence electrons. It needs just 1. So my product is going to be KCl, and my other product is not just going to be I. You have to remember it's I2 because it is diatomic. There's a ton of little things you have to keep track of. Now, what else do I have to do? I have to go back and balance my equation. So my products, I'm going to write them back up on the top, are KCl plus I2. Now, when I go to balance it, on this side, I have 2 chlorines, so I'm going to need 2 KCl's. Now I have 2 potassiums, so I'm going to need 2 KIs. And finally, I have 2 iodines and I have 2 iodines. So nice and neatly, my reaction would be written on the bottom. So there's plenty of problems for you to try on this sheet. Make sure you always refer to the activity series. You would be given the activity series on a test, even if you were taking a test in class, so you don't need to memorize it. As you go on, we would have done a lab in class that we would have found the activity series of several metals by testing them, but that's a little bit challenging to do now online. So for right now, just use the activity series, work through the problems. You do not need to turn it in. You don't have to do them all, just do enough until you're comfortable getting them done. That's it for now.